This is Algebra 2, Lesson 84, and this lesson covers degree of equations and solutions to systems of equations. The degree of a term of a polynomial is the sum of the exponents of variables of the term, and we went over this in Algebra 1. So this one is a 0 degree term. This one would be a 3rd degree term. This one, you count them all, so 1, 2, 3, 4, 5. That's a 5th degree term. And this one just be a 1st degree term, because there's only one, right? It's implied that it's 1. So when you're doing a polynomial equation, of the degree of a polynomial is the same as its highest degree term. So if we had 3x squared plus 2x plus 5, its highest degree term is going to be this x squared. So that is a 2nd degree polynomial. Pretty easy. A linear equation is going to be an equation that its highest exponent is 1 with 2 variables. Alright, so here are all the linear equations. When we have systems of linear equations, there are 3 possibilities for the number of solutions. Alright, so this one, we're going to graph these real quick. So this first one, A, we've got y equals x plus 2. So 2 is going to be my y-intercept, and then just x, that means 1 over 1. So that's my slope. Alright, and now I'm going to mark that little line. Good enough. Alright. And then this other one is negative 2x minus 1. So that means I'm going to go down 1. And negative 2x means negative 2 over 1, down 2 over 1. Down 2 over 1. Or back 1 up 2. Back 1 up 2. There. Mark that with a line. Alright, so there they are, and they cross right here on this point. And when we solve this, we're going to find out exactly what that point is. So if we said we could use substitution, so y right here, we're going to substitute that into this equation. So x plus 2 equals negative 2x minus 1. And then we would do plus 2x. And we would get 3x plus 2 equals negative 1. And then we do minus 2, and we get 3x equals negative 3. So x is going to equal negative 1. And if we go look on here, our x value is negative 1. And then if we said y equals negative 1 plus 2, that means y equals positive 1. Okay? And that is true. Y equals positive 1 right there. So that's our point. Right there. Where they cross. That would be negative 1, positive 1. Alright, let's look at this. So that is the first possibility. There are lines that cross each other, and they cross at one specific point. Those are mostly what we've been working with so far. Alright, let's try this next one. So this one is, we're going to change colors here. X minus 2, y equals x minus 2. So that means we go down 2. And then we go 1 over 1. So there, 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 like that. Okay, now this next one, we have to move this around. We've got to divide everything by 2. Solve this, so we're going to have y equals, divided by 2 will be 1x minus 2. And you notice something, it comes out exactly the same as that one. So that means that both of these lines, another line, would be right exactly on top of that one. Those are actually the same equation. Right, so your other possibility is that they're overlapping lines. They overlap. Write that better. One is right on top of the other one. They're the same line. Alright, now if we went to solve that by using substitution, say that we took this bottom equation, 2y equals 2x minus 4, and we substituted that in for x. So we have 2y equals 2 times x minus 2 minus 4, and we would have 2y equals 2x minus 2 times 2 is 4 minus 4. Wait, did that wrong. Hang on. I need to sub it in the other side. And get rid of all this so I have more room. Alright, 2 times y, which is x minus 2, equals 2x minus 4. So I'd have 2x minus 4 equals 2x minus 4. You see how they're equal all of a sudden here? So if we try to get our x's together, we're going to get negative 4 equals negative 4. So you're just going to end up with two numbers that are equal. It'll be a true statement, but you can't come up with any solutions. Because every possible solution, no matter what numbers you put in there, they're going to come out the same because they are overlapping lines. It's really the same line. Alright, and then the other possibility is going to be an equation that looks like this. Okay, the purple is that one. Alright, so this one is 2x plus 2. So plus 2 means we go up here. And then 2x means 2 over 1. So we go up 2 over 1. We could go down 2 backwards 1. Okay, undraw a line for that. Okay, and then 2x minus 2. So that means I'm going to go down 2. And then 2x means 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. Draw a line for that one. And look at that, they don't cross. They're parallel lines. And we can tell that because their slopes are the same. This one's slope is 2 over 1, and this one's slope is 2 over 1. And these points are not the same. Okay, so their y-intercepts are not the same. That means they're going to be parallel lines. Alright, so if we try to solve one of these, we said, let's say that we subbed in one of these values. We'll just have to set them equal to each other, or we could subtract them. Let's see. Those would cancel, and we'd end up with y. No. We'd end up with 0 equals 4x. We could say 2x plus 2 equals 2x minus 2. We're going to end up with a statement that doesn't make any sense, like positive 2 equals negative 2. So if you try to solve one that has no solution, you're going to end up with something that looks like that. Positive 2 equals negative 2 isn't true, so that can't be a solution. So you'll end up with something that's false. Parallel lines never cross, so they have no solution. These lines overlap, so they have an infinite number of solutions. These have no solution, and these only have a one solution. So lines cross. So the first possibility is they cross, and they have one point in common, one solution. the lines overlap because the equation describes the same line, they're going to have an infinite number of solutions. And the lines are parallel and have different intercepts, so they'll have no points in common, no solutions. All right, a system equation that has at least one solution is called a consistent system. So that's going to be systems A and B. So if we go back and look at those, that's going to be our blue lines. Okay, they cross and they have one spot. And the ones that overlap, they're on top of each other. A system with no solution is called inconsistent. That's going to be your parallel lines. A system of equations is a dependent system when one of the equations in the system contains all the solutions common to the other equations. All equations are the same line. Otherwise, the system is independent. So dependent system is going to be, this middle one is a dependent system. Okay? Dependent system, when one equation, they all depend on that one line. All equations are the same line. Otherwise, the system is an independent system. Systems A and C are independent. So if we look at A and C, that's going to be cross or parallel. Those are independent. So dependent means it's the same line. And then consistent means that there are solutions. Okay? No solution is inconsistent. Dependent is the same line. All right, there's only one practice problem. Go ahead and see if you can work that, and then come back and press play. All right, is the following system of equations consistent or inconsistent, dependent or independent? All right, so for this, we could see if we could solve these. Let's see, we can move this around to be, if we've got 3x minus y equals -2, we could say minus 3x. We could say negative y equals -3x minus 2, and then we could change all these positive. So we've got y equals 3x plus 2. Oops. Okay, and then this one was 2y equals 6x plus 5. So if we substitute that value in right here where this y is, and we say 2 times 3x plus 2 equals 6x plus 5. We could get 2 times 3 is 6x, 2 times 2 is 4. And then when we try to subtract this, we come up with 4 equals 5. That is a nonsensical solution there, so that means that this has no solution. Another way to tell that would be to divide every term over here by 2, just to try to put it in y equals mx plus b form, and we'd have y equals 3x plus 5 over 2, and that tells us our slope is 3, and over here our slope is 3. But here our y-intercept is 5 over 2, and here it's 2. So those are parallel lines with the same slope, but a different intercept. All right, so what does that mean? When we have parallel lines, we need to tell if it's dependent or independent, if it's consistent or inconsistent. So consistent means that it does have some sort of solutions that match up, and this does not. It has no solutions that match up. There is no way to solve this. Those lines never cross. They're going to be parallel like that. So this one is inconsistent. And remember, a dependent one, it just means that the equations are equal to each other, that it's describing the same line. This isn't describing the same line. This is describing two separate lines that are parallel, never cross. Okay, so that means that this is independent. Okay, so the answer is inconsistent and independent. All right, and that is it for lesson 84.